Hello, boys and girls. This is Mrs. Harrell. I'm excited to begin something new today with you, and that will be creating lessons and helping you as you walk through the actual instructional page in your book, in your math book. But today's lesson is going to be a little bit different because I'm actually going to ask you to return to page 287 and 288 in your practice and problem solving book. This is the last lesson that you completed for Remote Learning Day 6. So if you do not have that in front of you, please pause the video at this time and go get your math book and open up to page 287 in your practice and problem solving book. You're also going to need something to grade your work with. Okay, so go ahead and pause the video, get what you need, and then come on back. All right, for those of you that are not sure what the goal was for this chapter in lesson 25, the goal was all about volume. Okay, and understanding what volume is and looking at 2 or 3 different ways that we can get the answer to volume. But one of the first things that we need to understand is what is volume anyway, and how is volume similar to area? So I'm going to show you something here on my screen, okay? So area, if we think about a cereal box, okay, area would be the front of the cereal box. So let's say this is 5 centimeters and this is 2 centimeters. So the front of the cereal box would just be the area, okay? And that would be 5 times 2, which is 10 centimeters squared. Or we could say 10 square centimeters, okay? What's different today, though, is when we're finding volume, notice in this shape here that I gave you, we can't fill this shape up because it's flat. So volume is measuring the amount of space that a shape can hold, okay? So we're going to take this 2D shape, and we're going to turn it into a 3D shape, which is what volume is. Volume is 3D, okay? So if we take that same, I'm just going to make it a little bit larger, okay? But it still would represent the same thing. We want this box to hold our favorite cereal. So let's say your favorite cereal is Captain Crunch. You want it to hold the cereal. That's what we're looking to find, is the volume, okay? So the volume, what happens is the reason this moves from a 2D to a 3D is we're going to stretch it out, pull it out, okay? And then we're going to close that part up, okay? So I'm going to fix that a little bit. Not liking that. So I'm going to go back over here. I'm going to try to draw that a little bit straighter. I don't know if that was any straighter. Live and learn. Hopefully I get better at doing this. Okay? All right. So I'm going to close that up here. Goodness sakes, it shouldn't take that long. Okay, so I'm going to leave it at that. All right, so I'm going to go ahead right now, though, and this is a box, okay? It's 3D. It's holding volume, okay? So it's similar to area, but we actually are going to fill this box. It's the space inside, where area is just, let's say area would be just this front space of the box if we were comparing the two, okay? So that's something really important to know. A rectangular prism, this is actually a rectangular prism because this is a rectangle. And when it's called a prism, we pull it out so that we can have volume, okay? So that we can fill it, okay? So when we have our final answer for this, we call that cubed. So let's say it's centimeters cubed or inches cubed. This, remember, was square centimeters. So we could say square centimeters, but here it's always going to have a 3, okay? So let's say this is 5 and this is 4, and when we go back, this is 2. Well, how would we draw that if we were looking at it layer by layer? So what this is saying is we're going to have 5 layers going up. So we're going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? And my layers are actually even going, we need this to go back. Okay? And notice that this is a 4. So this means we have to divide this into 4 equal parts. So I'm going to first divide it in half. So notice I have 1, 2, 3, 4. So that matches the 4. And I have 1, 2, 3, 4, 5. That matches the 5. Okay? Now I see I got a 2 here, but I only have 1 box. So how do I change that? I create a line. And now I have 1, 2. Okay? So each layer has 2 going back, each layer has 4 across, and each layer we have 5 total layers. Okay? So then I need to close this up here and finish this off. Okay? So what we created right here is a rectangular prism. Okay? And if we're going to count these layer by layer, 1, 2, 3, 4, 4 and 2 back. So we got 4 here we can see, and there's another 4 back here. So that, if we look at that, hey, that's a math multiplication problem, that's 8. Now, what we have to remember is this is 8. Then this would be 8. And this is also 8. We have 5 layers of 8. That could be the same as 8 plus 8 plus 8 plus 8 plus 8, or we could simplify it by multiplying 5 times 8, which is 40. And because this is cubed, we can either label it cubed centimeters, or we could say 40 centimeters cubed. Okay, now where did that centimeters come from? Good question. I never recorded this, but let's say this was centimeters. Then my answer would have centimeters. If this answer was inches, then my answer would be inches. Okay? So that's just a little background information that we got to understand that what we're doing here, what our goal is, and we're going layer by layer. That's how this lesson is set up. Okay? And then we're going to build on that tomorrow. All right. So now let's go to our lesson, problem solving. And let's look at page 287. So hopefully you're seeing now that I've got page 287 in front of me. I'm guessing some of you may have forgot the importance of these boxes, okay? So I'm just going to scroll up and I'm going to remind you that you should be using these boxes as to help you. They're very important, okay? There's one other thing that I want you to get into the habit of doing. It would help me greatly when you're submitting your work. Of course, you're going to put your name here. And today is actually remote lesson. This one was from 6. remote lesson, and it was from 4-2. So at the top, I'm going to ask you to do the same thing on the back side. Put your name. And I would do this before you even get started all the time. Today, this is remote lesson 6. And that was the date that this assignment was given. That's the date that you always want to put, not the date you're actually doing your work, but the date the assignment was given, so that when you finally submit this to Mrs. Harrell, I'm going to give you credit for that. Just as a little heads up, yesterday alone, just yesterday, I got 79 math assignments submitted on Class Dojo. And I'm trying to figure out and read these in a little picture. So it's been a little bit overwhelming, and I'm pretty sure this little idea will help me greatly. So I appreciate you doing that on both sides. That way, when you go to take a picture and submit it in your class portfolio, you're going to also know what you're submitting, okay? And you can check it off that sheet, that Google sheet that I sent your parents. All right, let's get started. All right, if you have any reason to take a pause for a second and come back to this, this is the time. Otherwise, we're going to go ahead and get started. So here we go. What is the volume of the rectangular prism? Okay, so first thing I want to understand, why is this a rectangular prism? Well, it's rectangular. Okay, there's my rectangle. It's a prism because it's 3D. Here's my area. This is what we were just talking about, but if I pull that out, I'm making a shape that holds something, volume. That's why I'm using the word volume here, or they're using the word volume. In this case, they're saying over here, how many cubes are in each layer? Okay, so we can count those. There's a couple different ways we can do that. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 in this layer, which would mean there'd be 8 in this layer, and 8 in here, and 8 here, and 8 here. Okay, and I've got 1 layer, 2 layers, 3, 4, 5, right? So what I can think about is that I have 1, 2, 3, 4, 5, 6. Whoops, I just messed that up. This is not 8. This is 6. 1, 2, 3, 4, 5, 6, right? We can see 6, but there's a second layer back here that's also 6. So this is actually, each layer is 6 times 2, which is 12. If we have 12 here, remember we can see part of them and half of them we can't see. Then this is 12. This is 12 more. And this is 12 more in this layer. And 12 more, and so on. Okay? And if we have 12 in each layer times 5 layers, then we can multiply that out. And I like the idea of just simply thinking about 5 times 2 is 10, and 10 times 5 is 50, and that gives me 60. So the correct answer is 60. Let's move on to number 2. What is the volume of this box? Again, I'm going to volume. I'm filling this box up. Okay. Now, I want to come over here real quick and glance at this. How many layers of cubes will there be if you fill the box? Well, I can actually finish this box, and you should do this too if you're not doing this yet. Use those lines that are there to guide you and build right off of them. Now I've got to bring, this one is really tricky up here, okay? Now we can see that we have 3 layers. Here is a layer, 1, 2, 3, 4, 5. That's why this is 5 centimeters. They go back 2, 1, 2. That's why this is 2 centimeters. So what is 5 times 2? Well, 5 times 2 is 10. 10 centimeters cubed, right? And we have 3 layers. Here's 1 layer, 2 layers, 3 layers. So our answer should be 30 centimeters cubed. Okay, so notice I did that before I went on to the rest of the question. I actually went and solved it. Did it ask me to do that? No. Should I do that? Yes. Okay, now what is the volume of this box? Well, the volume of this box is 30 centimeters cubed. So I look at what is the volume? There's my answer. Okay. Cindy chose B as the correct answer. B? Why did Cindy choose B? Well, I could say, well, I don't know. Well, I want to look over here and see what could she have done. So I'm looking at these 3 numbers that were there. I used them too, but I multiplied. How could I get to 10? I'm going to notice that 3 plus 5 plus 2 equals 10 centimeters. So Cindy added when she should have multiplied to find volume. Okay, and here I already is my example is right there too. All right. Number 3, draw or describe a different rectangular prism that has the same volume as the prism in problem 1. Okay, so I'm not going to 2, I'm going up to 1. So up at 1, it had a different rectangular prism that has the same volume. So it's got to equal, some things I'm going to understand, it's got to equal 60. Okay, it's got to equal 60 cubic units. Right? It's got to have the same volume, but it's got to be a different rectangular prism. So it can't be this same prism. I can't do that again. I have to do a different prism. Okay? So what I'm thinking about is how could I do that? How could I get 60 to be my answer if I had 3 measurements that I'm going to multiply by? So what would this factor be, and this factor, and this factor be? Okay, so some options, I might think about just cutting this 60 in half and making it 30, and knowing that if I have 30 times 2 times 1 gives me 60 cubic units. So I could do that, or I could draw a picture. Okay, could I do something else? Is there another option? Well, if I break this into half, what would I want to do to the 2? Do I want to break that in half or get larger? I would want to get larger. Okay, so if I cut 30 in half and get 15, then what do I want to do with the 2? I want to make it a 4. And then I could say times 1 again, all right? And that would be 60 cubic units. That's another option. Okay, are there other options? Absolutely, but we're going to stop right there. Okay, or you can have your answer can still work. All right, Which expression, so I'm going to underline that word, can be used to find the volume of this rectangular prism? Okay, so things I'm going to stop and think about. What is an expression? Well, an expression doesn't have an equal sign. That's the only difference. Remember, an equation, you can see the word equal, so it has an equal sign. An expression does not. That's simply the difference. If I put an equal sign here, this just became an equation. If I put an equal sign there, it's now an equation. If I put an equal sign there, I've changed these expressions into equations. That's it, right? Volume. So volume is I'm going to fill in this big thin tower, okay? So circle the letters that apply. I'm going to come back over here. There is more than one way to find the volume of a rectangular prism. Well, one way is I could go layer by layer. 1, 2, 3, 4, 5, 6. This is a 1. And how many? 1, 2, 3, 4, 5, 6. I'm going up. So, is 4 involved? Do I have a 4 over here? Nope. So that can't be it, right? Do I have 6 groups of 6? Well, 6. 6 more, 6 more, 6 more, 6 more, 6 more. Yep, that's going to work. Do I have just 6 boxes here? No, because this right here is 6 cubes, so that isn't even possible. And notice I also only have 2 factors. Volume, this would be area, because there's only 2 factors. So that is one I can eliminate right off the bat, okay? Now, 6 plus 6 plus 1. Well, that would be this, and this 6, and 1 more. Is that what I have as 1 more? No. 6 times 6 times 1. Well, if we remember what we just did on the other side, we multiplied instead of repeated addition. We did 6 times 6 times 1. Absolutely, this is going to work. Okay, next one. If you add 2 layers to this rectangular prism in problem 4, how much greater is the volume? All right. Well, first of all, I didn't even solve for the answer up here, but I can quickly go and do that. 6 times 6 times 1 equals, well, 36 cubic units. That's what's up here. I could also count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 18, 24. So I can count if I wanted to do the counting, but it's easier for me to multiply. So I'm going to stick with that. Now, how much greater if I add 2 more layers? So if I added another layer, this would become 7 layers and 8 layers, right? So here, now my expression is going to be 8 times 6. Doesn't change. It doesn't change my the length times width times height. It doesn't change this. It's only going up another layer. So I'm putting another layer up here, and I'm putting another layer up here. Okay? So that's the only number that needs to be changed. All of these numbers are going to stay the same. So 8 times 6 is 48. 48 times 1 is 48 cubic units. Am I done yet? Let me go back and check. If you add 2 layers to the rectangular prism in problem 4, how much greater is the volume? Oh, wait a second. I didn't answer that. I gave the answer to this, but the how much greater is that's the difference between here and here. Okay, so what's the difference? Well, I could look at it, I could go ahead and do 48, take away 36, or I could have simply thought, well, this layer was 6, and this layer is 6. So 6 plus 6 is 12 cubic units. Lots of ways I could look at this answer. All right, next one. Mr. Carlo is building a storage box in his workshop. The space where he plans to put the box is 5 feet long and 2 feet wide. Now, I'm noticing right off the bat he's got 5 feet because it's 5 feet long, which is the longer side, and then he's got 2 feet wide. That's how wide it is. And there's 2 boxes, 1, 2, 3, 4, 5. So that 5 and that 2, they correlate with the answers that they have here. Okay? He wants the volume of the box to be at least 36 cubic feet. So it needs to be at least. That means it has to be at least get to this point, but it cannot be more than 56. So it has to be between 36 and 56. How tall should Mr. Carlos make the box? Explain. Well, I can go ahead and I can make some decisions right now. First thing I'm going to do is, if I multiply 5 times 2, which I got that from here, that gives me 10. What could I multiply 10 by that would get me to that range between 36 and 56? I have to get to at least here, that's the minimum, and I cannot go over 56. So I'm just going to start guessing some numbers. So 10 times 4 would be 40. Would that work? Yeah. Would 3 work? No. Why would 3 not work? Well, because 10 times 3 would be 30, and that doesn't get me to 36. So already I know that it could be 4. Could it be 5? 10 times 5 is 50. Well, that would work. 10 times 6. Oh, that would get me 60. That would go over. So I have 2 choices. Okay? So I can either make my box right here. This could either be 4, or I could make one that would be 5. One, 2, 3, 4, 5. This is going to be 5. 1, 2, 3, 4, 5. And this is going to go back this direction. Okay? Oops. Yep, it's kind of sloppy, sorry. And it needs to be 2. So notice I've got 2. 1, 2, 3, 4, 5. And I've got it going up 1, 2, 3, 4, 5. So 5 times 5 equals 25. But I have 2 layers times 2. So I have 50 feet cubed. Or I could think about this one. There's 1, 2, 3, 4. This would be 4. I can think of 4 times 5 times 2. 4 times 5 is 20. 20 times 2 equals 40. Okay, and then I have to label it feet cubed, right? I'm going to go back. He wants the volume of the box to be at least 36 cubic feet. Well, this one is. So is this one. But it can't be more than 56 cubic feet. That applies. How tall should Mr. Carlos make the box? Explain. Well, here I could say he could make it the box either 4 feet or 5 feet tall. And here's all, I've already got all the work done. Okay? So again, understanding the big things that we got to understand. Volume is 3D. It's filling in the space. Okay? What a rectangular prism is. Here's a rectangular prism, rectangular prism, rectangular prism, rectangular prism, rectangular prism. Okay? Understanding how to label a cube or label with volume. Okay? So hopefully this helped you out a little bit, and those are going to be some really solid, important things for you to understand before we begin lesson 26 tomorrow. I hope you enjoyed and as you found this helpful. I will go ahead and try to do this for the lessons, typically out of the instructional book, not typically going through the actual lesson like I did today, but using the videos more to teach the lesson. You will do your workbook, problem-solving book on your own based on the lesson. Okay, so that should help you and your parents out. But for today, I just wanted to make sure we were looking at this workbook page before we move on. All right, we'll talk again soon.